So now we'll move on to the next topic, that is floating point processors. Here floating point processors are nothing but they are similar to the fixed point processors. Only the change is that in floating point processors it is possible to execute and fetch the data simultaneously. Means here it can fetch, execute, decode, or it can also capable of performing multiplication and addition at the same time. So that's why floating point processors are more preferred than the fixed point processors, because floating point processors are capable of executing many instructions at a single time comparing with the fixed point. So we'll discuss this. We'll move on to that floating point processors now. So as I said, this is a floating point processor. So in the floating point digital signal processor, it can perform the DSP operations using floating point arithmetic unit. So here also we are going to use the arithmetic and logic unit to perform the operation, but the number system is in floating point. Whereas in the previous video we have discussed about floating point. So that's the fixed point. So that's the number system where we have used in the fixed point. Here the advantage of the floating point number system is that it uses a floating point processor, so which includes the getting rid of the finite word length, which affects the overflows, round off errors, truncation errors, and the coefficient quantization errors. So here in the fixed point format, there we have to face the problems like we have to get the result within the range of 3 to minus 4 if it is a fraction part. Otherwise, if it is a Q15 format, then we have to fix the output range within a particular bit or within a particular range. So otherwise we have to face the overflow in the fixed point format. So that can be avoided, or that is the advantage in floating point format here. So there we are facing that problem, but here we can eliminate that problem using floating point format here, like overflows, round off errors, quantization errors. So because here in the floating point we are capable of coding the instructions, so we do not need any scaling input samples to avoid the overflow, shift and accumulate a result to fit the DAC word size, that is digital to analog code word size. So here floating point allows us, by writing the code we can limit or fix the result within the particular range. So now this is the typical the architecture, which is taken from the Texas with a series family name TMS320C3X. This is the name of the family which is manufactured from the Texas Instrument. So now what it consists of? So that is important here. So here it consists of then input output instructions, that is these are the connecting ports which are used here, like ready, okay, input output strobe to turn on or to turn off the device, like data pin starts from 0 to 31 bit, then address pin starts from 0 to 12 bit, then master strobe just to control all the operations of data bus and peripheral bus. The same thing is written here also. So they are interconnected between any other devices. So again it is provided with program cache memory with the size of 64 cross 32. Then there is the RAM with block 0 and block 1. So two RAMs are there. We call them on chip program memories, which of size of 1K cross 32 and 1K cross 32. One read only memory with of block 0 with the size of 4K cross 32. The reason of using these things are, here using RAM we can perform read and write operation parallelly. Using ROM we can read the instructions present in this ROM. So here again we have provided with, there is a one CPU and one additional direct memory access. This is also called as another additional processor which is related with CPU. So this direct memory access acts as a processor which is used to generate the address and the control register instructions, and it is associated with serial port 0 and 1, then timer 0 and timer 1. and these devices are connected to the peripheral bus. So here direct memory access, this is a kind of processor, allows to access the data serially using timer 0 and timer 1 kind of registers. These are two 16-bit registers which are also used in controllers also. So using peripheral bus, they can access to the DMA processor. Within DMA processor, we have an address generator and control register. Address generator to generate the particular address required to perform the operations by fetching the instructions and executing the instructions. Control registers to control these operations which are operated parallelly. Okay, like if you want to fetch the data from serial port, or if you want to fetch the data from the data bus, including read or write memory or read memory. So here the next is CPU. CPU holds the integer floating point multiplier and the integer floating point ALU. So it has both multiplier and ALU which supports the floating point integers. So from this I can say that it is capable of performing addition and multiplication at a single time. So that is the one advantage of this floating point processor, because the CPU has both floating point multiplier and floating point ALU. So combination of these two, now it is capable of performing both the operations at the same time. Then it has 8-bit extended precision register which is used to hold the round off result or the extended result which is done after the operation of multiplier and ALU. So now it is, if I perform the multiplication of 32 cross 32 bit, this 8 extended precision register will hold that data which is extended from this operation. Again, it has an address generator and 0 and 1 which is required to store the result for and or to read and write the result for random access memory and read only memory. Then we have 8 auxiliary registers and 12 control registers. So these 8 address auxiliary registers and control registers, the main region of these two are, they are also of size 40 bit. Okay, these 8 auxiliary registers and 12 control registers, they are of the size 40 bit. They are used to maintain the accuracy of the floating point results, and again these 8 auxiliary registers can be used for addressing and for integer arithmetic. So like this is the CPU which gives us these options to perform the operations which are carried out in this floating point processor. Here this floating point processor is also capable of executing 60 nanosecond single cycle instructions. There's nothing but it is capable of executing 16.7 millions of instructions per second. Okay, so it has some pins which are provided here, like ready, which is this pin is active low, then interrupt pins, interrupt acknowledge pin, and then some are important like clock pin, supply, power supply, VDD, VSS. Few other pins are used but the information is not provided. So these pins are used just to control the operation of CPU and direct memory access processor. So ready pin allows gives the acknowledgement that the device is ready to perform the operations like fetch, decode and execute. So like this processor is used to perform the operations. Okay, so this is about a brief introduction about floating point processor. Hope it is clear for everyone. If you have any doubts, when I comes to the online, we will discuss about this floating point processor. Okay, so thank you.